the burning velocity is less than 10 centimeters per second. So it's a very slow burning flame. It would take burning over 6 pounds of R32 to equal the heat of combustion for 1 pound of propane. So just quick recap, we're going to talk about A2L refrigerant, really what that means, because of all the misconceptions we've had in the field, things we're hearing from our contractors, from our distributors, because again, people are fearful of A2Ls because they hear the word flammable. So I'm going to walk through this and talk about how they're classified and exactly what the dangers really are. So hopefully it'll put everybody at peace of mind. So first slide I'm going to talk about is what is an A2L refrigerant, or how are refrigerants classified? And so we'll look at the table showing an ASHRAE standard 34. And so specifically, I'll kind of address these things one at a time. So at the beginning of these refrigerants, you have either an A or B, okay? And A refers to a low toxicity level, meaning if you breathe this refrigerant, it's not gonna, put you into shock and burn your lungs like mustard gas, anything like that. It is a low toxicity refrigerant. Then you have the B classified refrigerants, which are toxic. Okay, so things like ammonia, other things. Then you get into the flammability of the refrigerants. Those are classified as either 1, 2, 2L, or 3. Okay. So the 1 classification, there's no flame propagation. It's considered a non-flammable refrigerant. With a 2L refrigerant, like R32 or R454B, it is slightly flammable, but the burning velocity is less than 10 centimeters per second. So it's a very slow burning flame. A2 refrigerants just mean that it's flammable. It does burn a little faster than the 10 centimeters per second. And there's also a restriction on the lower flammability limit and the heat of combustion, okay? And then you have the A3s and the B3s. Well, the class 3 refrigerants, those are very flammable. Those are gonna be your hydrocarbons, like propane and other things like that. So we'll move on. We'll just talk about the toxicity classification more in depth. So again, how the Class A refrigerants are defined. So a Class A refrigerant has an occupational exposure limit of greater than or equal to 400 parts per million. That means you could be exposed to 400 parts per million or more of this refrigerant without any real negative effects. And then you have the Class B refrigerants, which are going to have an occupational exposure limit of less than 400 parts per million, right? So less than 400 parts per million, you're going to start having some health effects with those refrigerants. Health effects can be, burning eyes, burning lungs, tachycardia, asphyxiation, things like that. So,
what is tachycardia?
Irregular heartbeat. That's what one of the different types of arrhythmias in the heart. So further, you can talk about the ISO 817, and that talks about acute toxicity exposure level, or A2L, of a refrigerant, which is used to determine the toxicity based on a practical limit. And the maximum value of that is set by what they call the limit of oxygen deprivation, or ODL. And that's set at 140,000 parts per million. That means at 140,000 parts per million, there's so much refrigerant in the air, you're going to start to asphyxiate, right? There's not enough oxygen for you. Well, when you look at the table 5 in ISO 817, and you look at all the different, the 90 refrigerants they have listed there, you take a look at R32. It has an A2L of 220,000 parts per million. That's the highest of all refrigerants in that designated table. That means it is the least toxic out of all those refrigerants. So again, what does that mean? You have far more of a risk of asphyxiating in a room full of R32 than you would suffer any other negative health effects. Okay, so that's how they look at the toxicity level in that classification.
So when I left my recovery tank cracked open by accident, and it was in the back of my truck and filled the cabin, start getting lightheaded, you turn it off. If that's never happened to you, I mean, do you even do this for a living? But what you're saying is that the toxicity, I would basically have to start getting lightheaded and stuff like that
Yeah, absolutely. And the lightheadedness will come from the fact that you're being deprived of oxygen,
Right.
not because of any chemical reaction within the body.
Gotcha.
The locking caps in the last few years have been a big thing because people pop them off, and unfortunately they use the refrigerant to induce a high. Well, again, with R32, there's no reaction within the body that occurs. What's going to happen is you're just going to have oxygen deprivation
I got you.
at that point.
So it's a safer.
Like going for a swim.
Yeah,
Yeah.
Staying in there way too long.
exactly.
James, I never did that. It was just a vacuum pump. I always knocked over it.
Oh,
And the oil
that's-
all over the back
Oil
of the
goes
truck.
That's the
everywhere.
quickest way to change your vacuum pump oil is to dump it out in the back of your van.
Well, that's when people change it.
Yeah,
That's only the only time when some guys tell you.
Yeah.
Yeah.
like the
learned-
oil in my truck.
I learned on
Just
that
leaks
Ford
out.
van, if you put it on the step, at least when you knocked it over, it knocked it off outside, not in the van.
Next thing we'll talk about is the ASTM E681 flammability test. It's actually very interesting. This kind of shows you a better picture of, A2L refrigerants are just not that big of a deal. Okay, so what they do in this test is they put refrigerant in a combustion chamber under certain temperature, pressure, air to fuel ratio, and they ignite it. And then they measure the flame, and they have a 90-degree angle there. So if you are dealing with class 1 flammability, which is no flame propagation, the flame spread is going to be less than that 90 degrees. Okay, so if flame falls than 90 degrees, it's considered non-flammable. With the A2 refrigerants, those are going to go outside of that 90 degrees. And as you can see on the picture, it's just barely getting outside of the 90-degree mark. And then to get the L designation on that A2, like I said before, your flame spread is going to be higher than the 90 degrees, and the burning velocity will also be slower than 10 centimeters per second. So again, if you look at that A1 combustion versus the A2L combustion, really not a lot of difference there. Okay, so it's very, very safe, slow burning. It's not explosive like a lot of people have this misconception about. But then you look at the A3 refrigerants, your propane, your hydrocarbons, things like that. Those are going way outside of the 90 degrees. They're much more energetic, much more bright. They're going to put off much higher heat of combustion, and they're going to have a much higher velocity when they burn. Okay, so those are the things to look out for. But again, I think most people in their homes have a refrigerator that contain those A3 refrigerants.
Right.
So they're already in your homes to begin with.
Right. One thing I always love to talk about is the low amounts of those refrigerants that are in these systems. And, if you did have a leak, you were talking about, a couple pounds of refrigerant. If you have a natural gas leak and, you don't have any kind of detection system, I'm not aware of it. Well, I'm sure somebody has one in a booth somewhere at AHR, but I'm not aware of anything like on my gas stove, for example, that has a sensor that would indicate that it's leaking. Right, and we have to put scent in it instead. Is what we did, right? So if my gas stove was leaking right now, there would be an unlimited amount of natural gas, right? Pretty much in my home, as opposed to like what I would get out at A2L. So going, with the A3, that's the flame spread that we're talking about. That's the kind of heat that it produces. That's the unlimited amount that you have going into a house right now with natural gas or propane. At least you have a limited amount, but it's an enormous tank outside. So.
Yeah, that's a good point.
Yeah.
So next topic I'll cover are the flammability limits. So what are flammability limits? Well, you have a lower and an upper. So the lower flammability limit is the minimum concentration of a combustible gas or vapor mixed with air that can propagate a flame. The upper limit, that's the maximum concentration, air to fuel ratio that can propagate a flame. So if you're below that lower limit, your mixture is too lean, there's not enough fuel, it won't burn. If you're above the upper limit, that means the mixture's too rich. There's too much fuel, not enough oxidizer, it won't burn. So I've got some common chemicals here with their flammability limits, upper and lower, as a percentage by volume of air. So if we look at, again, propane, I'm kind of picking on propane today, even though I'm from Texas, right? Propane has a lower flammability limit of 2.1 and an upper flammability of 10.1. Methane, natural gas, LFL 4.4, UFL 16.4. Ammonia, lower limit of 15, upper limit of 28. Gasoline, stuff that everybody loves to put in their car, has a lower flammability limit of 1.4 and an upper limit of 7.6. Isopropyl alcohol, rubbing alcohol you put on your skin or spray on your hair with your hairspray, has a lower flammability limit of 2 and an upper of 12. So what you have to look for when we're describing these, what's the riskiest types of chemicals? Well, it's going to be the ones with the low flammability limits, right? If something goes off with an LFL of 1.4 or 2, that means it takes only a little bit of that fuel mixed with air to be flammable. But then you look at our A2L refrigerants, R32 and R454B. R32 has a lower limit of 12.7 and an upper limit of 33.5. So it has to be fairly high in the concentration before it can combust. R454B has a lower limit of 11.3 and an upper limit of 23.6. Okay, so comparing those to those hydrocarbons that we use every day in our propane grill or our natural gas stove or natural gas furnace, it takes a much higher concentration to be able to set these off. It's also important to remember that within our GREE product, we have those refrigerant leak detection sensors, and those trip at a concentration limit of 10. So we will trip our alarms before we ever reach the lower flammability limit of that R32 refrigerant, because we want to make sure it never reaches the point where it can combust. It's going to trip the alarm, it's going to shut the refrigeration circuit off, it's going to turn the blower on, it's going to dilute that, because we never, ever, ever want to have a chance for that fuel to propagate a flame. And when we also look at these refrigerants, when they have to burn, and Greg did a great video kind of showing this, and we can show it here at the end of the slides. A2L refrigerants, they need a constant pilot flame or ignition source to burn. So if you spray the refrigerant directly on a flame, it'll burn. You pull the flame away, it stops burning. So it's got to have that constant pilot flame. So again, A2L refrigerants are very, very safe when handled properly.
Right. So on the lower flammability and upper flammability rating, just to try to connect two neurons, maybe for the audience here, is any kind of adjustment that you've made to a furnace. Like when you have poor combustion, for example, that's what you're doing. You're trying to get that natural gas, for example, and the oxygen mixture right in line so that you can produce the flame, so it'll propagate, so that it produces heat and all the rest of that. Or to liken it to, small engines or whatever, if you got a carburetor, you take a look at the upper flammability limit of 7.6, you got a flooded carburetor, it's higher than 7.6, and we know it doesn't burn, Yep. I found that out every time I crank my lawnmower. I'm just flooded every single time. But we got numbers and all that, but that's what we're related to. So what we have to have for A2L refrigerants in order to combust is, the right conditions would have to exist. And those conditions are going to be very rare.
Absolutely.
You almost have to go out of your way to make those conditions.
Those conditions would be much more common when it comes to like a furnace, natural gas.
Absolutely.
We hear about that once in a while on the news. A pilot light was just, thermocouple wasn't working. The pilot lights, it kept flowing gas, and then you end up with an explosion. And that's not the type of thing that even could happen in these instances when we're talking about heat pumps and our R32.
Right.
It's less likely.
And again, those natural gas appliances don't have leak detection sensors in them.
Right.
If it leaks, it leaks.
Right.
And like James likes to say, you won't find out until you come home and turn the lights on.
Yep, that's right. Well, and of course, then also those conditions have to be perfect enough as well.
Right.
But no, I was actually asked a question yesterday about one of the booth visitors. His concern was if you had a grounded compressor, right, with the flammability, right, and it was very hard for me to explain what I was talking about here. But I think these numbers would work really well in a system that should only contain R32. You're going to be well above the upper flammability limit of 33.5. So you would have to have enough air in that system in order to do that.
No vacuum. Didn't pull a vacuum at all.
No vacuum at all. A little bit of refrigerant.
Yeah.
It's not going to be a whole lot.
Just a little.
A little bit of refrigerant, and then you would also have to have a grounded compressor with a hot enough spark and all the rest of that. Look, I see videos. People will say, you've seen them too. I mean, they're like obviously AI videos, but people share them. It gets, even comments that are just negative comments like this is a fake video and all that. It's for engagement. That's how they get money. That's exactly what they're doing. I've seen some very obviously fake ones, and they're shared like
They're just
they're
trying to go
absolutely
viral.
true.
They're just
Yeah.
trying to get views.
Well, let's
It's
be
a really
real.
limited audience, but try to go viral with it.
Let's tame it down a little bit for the audience. So, for guys like myself that don't have a doctorate like Dr. Justin, with all of the fancy technologies, their names, it's air fuel mixture.
Yep.
Yeah.
It's air fuel mixture, so you're not going to have the right air fuel mixture inside that compressor, inside that system, to actually give you a flammability or explosion or anything like that. Yeah. So it's the chances of you having that right air fuel mixture inside that refrigeration circuit is slim to none.
Right.
The chances of you having that right air fuel mixture in somebody's home is next to none.
Exactly. And what's funny is people don't realize it, but under the right condition, even 410A can combust. Now, it won't happen under standard temperature and atmospheric pressure, but under the right conditions,
Right.
it can combust. And we saw that, they have an A1 refrigerant flame test.
Wow.
The things can,
Right.
can
So
take
it
off.
does burn.
Yeah, it can under the
It
right
can,
conditions.
If you hold a torch to it while you're trying to weld a compressor shut.
I can attest to if you atomize POE, you can also burn POE.
Yeah.
I know a guy right now that missed his mustache right after that. But you can cause the same thing. So if you've got a real hot torch, you can pretty much light anything on fire.
Yeah, that's a good point. A lot of times the refrigeration oil poses more of a danger than the refrigerant.
Than the refrigerant itself.
Yeah.
This is excellent data.
Yeah,
you've
yeah,
provided
absolutely.
here. I think this is just one of the most comprehensive explanations of the flammability of it that I've seen.
Yeah.
Yeah, I thought it was excellent myself. Very good job, Justin.
Yeah,
Thank you.
it's really good.
To kind of further drive the point home, I want to talk next about heat of combustion. Well, what is the heat of combustion? Well, heat of combustion, that's the amount of energy gained or released from burning just a volume of gas, right? It's how many BTUs you're outputting. So let's look at heat of combustion of some common chemicals, all right? Propane. If you burn a pound of propane, you're releasing 21,500 BTUs approximately. Methane, natural gas, 23,800 BTUs per pound. Gasoline in your car, 20,400 BTUs per pound. Coal, anthracite coal, you burn a pound of it, you're going to release 13,000 BTUs per pound. All right, big numbers. So remember, when you're grilling your steaks, your burgers on your propane grill, for every pound of propane you burn, you're releasing over 21,000 BTUs. Well, now let's look at R32, our malicious A2L refrigerant that everybody's scared of. If you burned a pound of R32, you're going to release 3,869 BTUs per pound. It would take burning over 6 pounds of R32 to equal the heat of combustion for 1 pound of propane.
So what you're saying is we don't want to barbecue with it.
It'll be very expensive
Very expensive.
if you can
brisket.
keep it lit.
Yeah. Even more expensive than brisket already.
Terrible,
is.
terrible steak.
Yeah, it won't do much for your flavor.
Yeah, you get a rare steak, not
Yeah.
a medium rare.
Well, being from Texas, I'll say that stick with propane
Yeah.
for your grilling needs.
Hank Hill would be
Hank
proud.
Hill would be proud. That's right.
God bless Texas. and again, just to kind of put a pin on it there, R410A, I talked about it burning under the right conditions. Even it will produce 2,800 BTUs per pound.
Right.
So again, with our A1s, our A2Ls, they're releasing very, very little heat compared to the hydrocarbons. And why that's important is because if you do have a flame with an A2L refrigerant, it's going to be very low heat. Well, if you want to burn something like plastics and other things, typically you need much higher heat to set those on fire, melt them, things like that.
Yeah, I mean, so basically, you're talking about everything being on fire already. Pretty much, right?
Pretty much.
You're talking about you already got a fire going, and that's what we're talking about it. So then you've got 410A that would effectively have like a lot of the same properties. I mean, you're not using 410A to put out fires.
Right.
Right. So yeah, it's actually a really good point too. I mean, I like the numbers here. Shows that A2L refrigerants are a terrible fuel.
Yeah.
So,
They really are. And that's and from an engineering perspective, I think some people glaze over when you talk about that, but I think the data always speaks the truth. Right. We can have all this marketing speak. We can pat everybody on the head, say it's going to be okay. But until you actually show the data and people understand it, I think that's the best tool we have to fight this misinformation out there.
Yeah, and I think too that unfortunately, we talk about it from the concerns that people might have around it so much, so that it kind of overshadows the advantages that some of this provides. I mean, we are able to use less refrigerant, for example. So you look at the BTU output there. If I double the amount of, I would have to double the amount of A2O refrigerant I would have to have in order to get to what R410A would be, right? As far as, I mean, I don't remember what the numbers were, but effectively I'd have to have a lot more of it, right? Well, so I'm using a lot less A2O refrigerant right out of the gate, right? And that's one of the advantages that we have. In addition to, higher discharge temperatures, we get to use that to our advantage since we use high discharge temperatures in order to get you heat at minus 22. It may not be an advantage for somebody who doesn't use inverter-driven compressors, who doesn't try to do ultra heat, like regular standard stuff that you might be buying all the time, right? That's something they got to build in. They're going to have to maybe lower their capacities a little bit or something. But we can use that to our advantage. And then finally, just the efficiency ratios. Yeah. They're naturally higher.
Yeah.
Just switching refrigerant. Of course, there was some R&D around, putting the sensors in and all the rest of that. Which, I mean, as far as sensors go, globally, they have these sensors already built in. And
No, this was a specific requirement for North America under UL. But again, globally, they've
like
been
a
using
billion units that don't have them.
billions of units out there over the last 10 years that didn't have these refrigeration leak detection sensors in them. And those countries are still standing. They haven't burned down.
And also, we don't technically have to have them in some of the smaller systems that don't contain enough refrigerant for them to be required.
9 and 12K,
We just chose to have them included because we use indoor units on multi-systems and single zone. So if it's used on a multi, you may have the amount of refrigerant it requires. So we could have chosen to not have sensors on the 9, 12Ks.
Right.
But,
But on the 115 volt, we don't have them.
Yeah, so there's always exceptions to the rule. It's on our 115 volt 9K and 12K. We don't have the sensors. That's just because they're not compatible with the multi-zone, the 230 volt multi-zones. But the limit on that is a system has to contain more than 1.8 kilograms of refrigerant to be forced to have that sensor on it. And a lot of our systems, they don't have 1.8 kilograms, or it's about 3.9 pounds.
Oh, there we go.
So, sorry.
I like the pounds. That makes more sense to me.
I'm all for adopting the metric system moving forward.
He's a big supporter of Jimmy.
Just trying to confuse us.
Dr.
peace,
Justin speaks
What's a
again.
kilogram?
Yeah.
Yeah. Two something. I don't know. I was asked earlier if I was over 100 kilograms. I'm like, yeah, I'm over 100 kilograms. That was pretty quick, Times 2 was enough for me.
Yeah.
So make that determination. No, that's a lot of good information, Justin. I really appreciate that.
Yeah.
That's good.
So just real quick, just key takeaways. If you walk away with nothing else out of this, just know that A2L refrigerants have been used safely and successfully around the globe for over a decade. Okay, very, very safe product if you install it properly. But that goes with any product that you install, all right? Gree Equipment has the refrigeration leak sensors in the indoor units to mitigate risk from indoor coil leaks. And like I said, they trip at 10% concentration. Lower flammability limit of R32 is 12. So we're never going to let it get rich enough to burn. And then as always, whether you're installing equipment or using a brand new tool or leak detection tool, always follow the industry best practices for everything you do. Follow your local codes and always follow the manufacturer instructions. Please, RTFM, read the factory manual, right? It's very important. So thank you. That's all I've got.
That was really great.
I like that.
Yeah.
So I shouldn't
the
use it for
factory
a knee
manual.
pad.
Don't use it for a knee pad.
That's not a knee
and,
pad.
And it's
there
not
for a
just
reason.
it's not just about safety. It's about installing it and not having to go back in 2 weeks because something's not working properly. So following the manual and installing it properly keeps you from having to call Greg and ask him what's wrong with it.
We see the memes on the talk groups and all that. You get paid for what you know. Okay, what you can know is in that manual.
Yes.
It's in our videos. It's in all that. So if you want to keep getting paid for what you know, get paid for what you know. Get your knowledge up, and that's where you command those prices, right? And if if you're not making enough money where you're at, well, there's other places. But
I had a boss at one point that asked me a question. He said, "What are you feeding yourself with?" And he was referring to like not during work, like when you're focused, you're doing the job, but what are you doing to continue growing and continue learning after work? Mm-hmm. Like, what are you are you sitting down and flipping on Netflix and just watching a show, which is great. I love watching a show, but sometimes it's good to, go home and read a manual or watch a training video, or, you got a job coming up and you just want to, get familiar with the equipment before you go do that first install. And those are the guys that really stand out in the industry.
Absolutely.
We know them. We meet them here at the HR show.
See them every year.
They're here learning.
Yeah, right. Well, I mean, the continuing education goes far and away more than what is like the minimum required hours.
Just the checklist.
Just the checklist. I mean, anybody can do those. They're free. You get donuts,
Right.
stuff like that.
Coffee.
But and we've seen from the data, like our YouTube shorts and all that, we've seen people watching those at all hours, long after work's usually over. Sometimes we see them. I mean, I'll never tell your boss that, that you're watching them at 9 a.m. But hey, if you are, if you're going out on a call and it's related to an error code and you're going out there, well, hey,
That's part of the job.
Yeah, we don't have to tell anybody you watched the video before you got out there. You were there 10 minutes, got it fixed. Everybody's happy. Well, you look like a wizard.
You look like the hero.
Yeah, you're the hero.
Well, and that's what I say all the time. You can't know it all anymore. Industry, products are changing so fast. You got to stay up to date. You got to stay reading manuals. You got to be, watching YouTube videos and stuff like that. Just keep up with the product.
Yeah, I think all of us on the stage each been in the industry for over 20 years, and none one of us know everything. I mean, we learn something new every day.
That's what keeps it interesting.
Yeah, we do.
Yep.
Don't always want to learn something new every day, but it definitely happens whether you want it to be or not.
Sometimes it's an unwanted surprise.
Yeah. I mean, just like scars. You learn something. You learn something every time.